like a, thank you. There's a kind of as a city and a state and building, an apartment number conceptually. That's how we think of it kind of in New York, other parts of the world as well. First, you have to find the state that you're going to go to, then you have to find the city you're going to go to, then within the city, the street, and so on. And so IP addresses are like this numerically. The IP version 4, which we just call IP addresses, is a number. It's cut up into 4 8-bit segments, which are 0 to 255, and we separate them by dots. And so the number range is from 4 zeros all the way up to 4 255. Okay, and so for an example, 198.51, 100.5. So this means that we kind of, not exactly, but we first have to find the 198 network, then within it the 51 network, and then the 100 network, and then eventually the computer number 5. Something like this, but you can see it's an address that routes you over to a certain part of the world. And so we're gonna use this addressing concept to create different networks all around our city, and they all have to have an address because we have to know how to get to it. So it's a core part of this the concept. And so, yes, sir.
Can you just chime in on how somebody gets like an IP address or what, or maybe you're going to cover that a little bit later, but just like how that works, that somebody's 198 or, some other network is 198.151.51 or something like that.
Sure, thanks, Scott. Yeah, that's a good idea. So, there's these, so the addresses are ranging from 0 all the way up to this 255, 255, 255, 255. And conceptually, the addresses themselves are, if you're on an isolated network just by yourself, you can use any address. You're not supposed to, because some addresses are assigned to different people around the world. And you do this because you want a globally routable system. So some addresses are assigned to Google, some are assigned to Microsoft, some are assigned to your house. And so you have to have an address that fits with the rest of the world. And so there's different governing bodies that assign addresses, and then those governing bodies give them to lower bodies who give them to different companies and so on. So in abstract, I'm just talking about the fact that there is an address and it looks like this because we'll use this. But in reality, there's private addresses which anyone can use in their private network. And there's public addresses which are like this 198 address that you have to allocate from a governing body. And so, for example, the Mesh, we have 3 different allocations from governing bodies that allow us to participate on the public internet. And so that's about public addresses. Private addresses, they actually, almost all of them start with 10 in the first segment. So 10 dot something, something, something. And we'll see many of those later in this presentation. So there's some nuance, but basically addresses are, directing you down a routing path, like a post office box from one area to the next area. Okay, so we can create a basic network, and we use this word network now for the first time, where 2 computers somehow connect to each other with a wire, for example, or maybe wirelessly, and they each have an address. And as long as the addresses are next to each other or they're compatible, you can just begin communicating between these 2 computers. And so this is a very basic network. It's not very useful, but in this isolated network, you can use basically any address you want. And so here's 2 laptops that are communicating that way. But of course, that's not a very practical network. So, and they each had just one plug plugged into the other one. So on a broader scale, there's a concept called a router. And a router is just a special computer that has more than 2 or more connections to it. You can have one, but it's not a very useful router. So we're going to say a router is 2 or more. And what the router does is it has some kind of way of knowing which direction addresses are. Are they out one of the plugs? Are they out of a different plug? Which direction do we send the data? And so, for example, in the picture on the right, we can see that we can connect, say, 2 laptops and the internet all together through this special router box. And so this is where the addresses come in. The router is kind of like a post office where it redirects your information from one area of the world or city to another part of the area. But how does a router know how to do it? Well, as we just talked about, it has to have a list of addresses. And so we call this a table. a routing table of where to send things to. And so, for example, we could have a routing table that says, when we're going to 192.168.0.0, we don't ask any other computer for help. We don't go via anything. We just send it out of plug number 1. And if we want to go out to 0000, so any, then go out through this other computer, which is on plug number 2. And so this is a very simple table. It's either inside or outside. It's no other destinations. And the router just says, I either send it to somebody I know, or I send it to kind of anyone else. And so this is similar to, say, a post office with different zip codes. The local post office probably knows about the zip codes that are around you, but it doesn't know about zip codes that are in California, if we're in New York. So it'll have some kind of table of saying, if you're going from Midtown to the Upper West Side, put it into this truck. If you're going from the Upper West Side to the Bronx, put it in that truck. And so you might send things from Midtown to the Bronx through the Upper West Side. But if you're going to go to California, you might send it to somewhere in some giant facility in New Jersey, and you don't really care where it is after that. And so we call this kind of a default route, or any. And the idea is that we just don't know. So there's some body that's bigger than us that knows how to send it to the next group of people. And so we call this an any route. And so in this case, we have any, which is the internet. It's just everyone else, and then we have us. But if you have a network that's even bigger, say 2 or more routers, so now we have 2 or more routers that have 2 or more networks on each of them. So in this example on the right, we have 2 routers that have 3 networks. We have one network that's to the local laptops, one that's to the other router, and one that's to the internet. And we do that 2 times. And so, for example, you might have this scenario in like an office where people are wanting to print on each other's printers. They want to play games across it or share files. And so we can have many different routers. And the table looks something like this, where we say it's either going to us, it's going to the other router, or it's going to the other router's local network, or it's going to the internet, or it's going to the internet through the other router. And so it starts to get a little bit more complicated, but it's only about 5 or 6 entries. And so you can still make this manually if you wanted to. Don't worry about the numbers specifically. This is just an example of what it would look like. But it can easily get out of trouble. It can get into trouble pretty quickly. So if you have, for example, 5 houses that all want to plug routers into each other, or 5 offices or something like this, and you wire it together like on the right, then you might start to be in trouble because now you have 16 routes on every router, and adding a new router to the whole network is quite painful because you have to go to each of the other ones and add something to them, which isn't very fun. And what happens if something in the middle goes off? Yeah, somebody's asking a question.
Sorry, this is Scott again. Can you give us an example route on this like diagram, like what it, you know?
What do you mean, Scott? I don't quite follow.
On the table, like could you, if I wanted to send like information from one of these laptops to another laptop, like can you give like an example of like how that would look, I guess?
On this diagram?
Yeah.
Yeah, so if this laptop on the top, can you guys see my mouse?
Yeah.
If this laptop wanted to communicate with the one on the bottom down here, you would firstly go to this router on the top, and then you have a choice. You can either go to this one on the left, or you can go to this one on the right. And then you can go, those both could directly connect to the one on the bottom. And so this one on the top it'll have an entry for the network of the bottom laptop, and it will have, the next hop will be the one directly below it. I wonder if I can write on the screen. Let me see here. I can. So here's our original, right? This is not very pretty, sorry. I'll just say number 1, right?
Looks great.
Thank you. And this is our end, right? Beautiful. Are doing things online fun. And so you can either go, let me make a different color. You can either go this way, or you can go that way, right? And both of them have to go through some other thing right here. And so up here, you'll have an entry. So you can type text. I can. You'll say you know, oops. So let's say this is the end network, and you'll say, oops, via, and something like either left router or right router. Okay, and then you'll have to choose. You'll have to also say, for example, let me see. Because these are the same distance, you have one router here and one router there. You have to, before you set up this network, you have to make a choice. You can say, well, this one, it's cost of 10, right? Right. So it costs it's 10 hardness to go through the left, and it's 10 hardness to go through the right. And then on the bottom, it will just accept. And on the bottom has to have something that also says, we want to go to the top, and you can either go via the left, right, or and the same kind of thing at the top. So this is there's more advanced concepts about what happens when there's an equal path. But really, what you probably want to do is you probably want to choose something like, oh, by default, we want to go through the left. And if the left is gone, we want to go through the right. But one of the main issues here, I'm not trying to actually highlight how this works, but one of the issues here is if we, where's my pen? Draw. Okay. Anyway, one of the issues is what happens if the middle goes offline. So what if this one dies, and by default we're choosing to go through this one because it says 11 right here, and so the challenge with this network that I've shown on the screen here is that it's actually not set up so that it can handle different routers going offline. And if you add another one right here, you add another router right here, you have to go to all of these different routers and add more entries like this. And so it's a major pain to do this network. And that's the main thing I'm trying to show here, is that this is how it can work, but it's not very optimal. And so I'm going to show a better way in a second. Does that make sense, Scott, or is that helping?
Yeah, that helped a lot. Thanks.
Thank you. So the takeaway from this diagram is that it can get complicated and messy really quickly. And if you want to do it manually, just by hand, you have to type a lot of entries on all of the different routers. You have to make hard choices. And then you have to, when things go offline, it might not work the way you think it's going to work. So that's quite a problem. Okay, clear the drawings. Good. So we're going to introduce a concept called dynamic routing, which is going to solve all of this. What we learned so far was called static routing. And as I mentioned, you have to go to each of your neighbors and set up the neighbor to talk to all the other neighbors. And so that's a big pain. But suppose there was a way to ask every router to tell every other router what connection it has and all of the neighbors that it knows about. And so that's called dynamic routing because it's, well, dynamic. So we're going to do that now. And so in this case, we've modified this diagram where each router is independent. Every router just communicates with every other router. And what that does is we can easily add new routers by just plugging one router into any of them here, and they will update all of their tables of routes to all of each other. So it's resilient, it's independent, things can go offline, parts of the network can disappear, and there's no major issue. So we call this a mesh network. Other people, it doesn't have to be that word specifically, but we use this word. And the idea is that any router you can plug into, it will just absorb all the routes and it will connect and just give it to all the other routers. And so it forms one giant citywide private network. Okay, so NYC Mesh ourselves are largely wireless network. And so a wireless mesh network is still a dynamically routed network. It just happens to be wireless. And you share the routes with your neighbors just over a wireless connection. So it's exactly the same. And in fact, if you look at this diagram, here we see that there's a wire right in the middle between the orange and the purple. And so you can have a hybrid topology with some neighbors being wired and some neighbors being wireless. And largely you just have to overlap the different wireless areas so that they see each other. And that's the basics of it. The hard part is the dynamic routing protocol, which we've solved at this point in this diagram or in this presentation. But there's other properties that are probably useful for mesh networks. Firstly, it's kind of like an extended college campus network or a city-wide network, and it should be autonomous. So self-routing, there's no one central point, there's no server controlling or making the network function. It should be offline capable. So if any of the different routes go offline or the different routers break, the whole network should still work. So it should choose its own paths through the network as the network changes. It should be able to make resources available to the users. So if there's internet available, it can consume the internet and give it to the users across the network, make it available via a route or other services or data, for example. And all mesh networks are a little bit different. So some networks should have, they might have a high point or a super node. They might have an uneven topology where some nodes are bigger than other nodes. It might have internet. It might not, and it's all okay because we're just plugging all the routers together in whatever way it can fit, and they are all dynamic and they all make their own choices. So that's the basics of a mesh network. Some of the example hardware that we use a variety of these different models here. We use all of them at some point, but they're all different routers that are able to participate. And what this basically is trying to say is that the model itself isn't as important as the concept of dynamic routing and how you plug it together. So there we go. Oh, this is what it says. Yeah. So we use all the brands. We're open. We don't mind if we use open source routers, closed source, name brand. They can be free, cheap, or expensive, as long as they follow the same pattern that makes the network able to function. One of the routers that is quite popular in our network is the OmniTick 5AC. We just call it OmniTick, and it's a good price point for all of us. So that's one of the ones that's most popular right now. Specifically, so this is I added some slides from an Omni class because that's the thing that is something we try to do, is have classes about how to configure this router especially. But it's a router that has 5 ports. It also has a medium range antenna, so it can go 3 to 5 blocks. And it's kind of in this donut shaped pattern that allows it to fan out across many blocks, but it doesn't really reach the streets. So it's more like router to router. This is one of the basics of this wireless mesh network that we just talked about. And it's somewhat performant. For example, you can make a block network. This is the Parkside block that we did a couple months ago, or maybe 6 months ago. So there's 10 omnis, there's 5 uplinks. It hit 30 apartments, and we did all of this in 1 day. And there's more now, but when you have this working really well, all you do is you have to throw the network up, and you don't really have to worry about configuring it because it's self-configuring. Okay, so in terms of a design, hold on a second, too many messages. Okay. Yes, so we make, at NYC Mesh, we especially make a hybrid topology with many different stable nodes. These are kind of like the county or country post office. We have semi-stable nodes, which are kind of like your neighborhood post offices. And then we have some rooftop nodes, which are like delivery routes. And the stable connections maintain, the big tables, the big routing tables, and they share it to the lower nodes, not lower in terms of desirability. It's just, the ones that are online the most, they know the most about the network because they've been online the longest. And so this helps the network remain stable because we have some nodes that are going to always be there, or they'll be there for many years. And then some that might come and go on a weekly basis, or some we might have only for 1 year at a time. And we've had problems like that before. So this is kind of how we're doing it for New York City. Other areas might be different. And it kind of looks like this. This is actually an old slide. This is incorrect. Sorry, wrong. But we have all the different nodes exchange routes between each other. And so we have this kind of concept of these mini meshes within the mesh that are these stable regions, and they have large, tall buildings within those regions that try to connect across the regions, and shorter rooftops within them. And this is especially important in New York City because we have many very tall buildings along with very short buildings. And so we want to jump across, we want to skip across the tall buildings like express routes, and then we want to jump into the local neighborhood as soon as we can. So there's that. Okay, oops. Oops. Clear my drawing, good. Okay, so it looks kind of like that at the moment. Okay, so here's a small break. Does anyone want to have any questions up to this point? Since we're a little bit different format than normal, people might not be able to just raise their hands. So there's a lot more slides. So I just want to see if anyone has any questions. I see. Yes, indeed. I see Aubergine asks, what does BGP stand for Gateway Protocol? This is one of the mesh routing protocols, or it's just a routing protocol, a dynamic routing protocol that we can use to send the tables from one node to another. We use one called OSPF within the mesh because it's more dynamic than BGP. You know, we actually don't use BGP anymore, so I just forgot to take it out. Yoshi asks if we are IPv4 only. We are mostly IPv4 at the moment, mainly for historic reasons, because we haven't had an IPv6 allocation, and it's a little bit more challenging to use public and private addresses for v6 in a combination. So at the moment, we're mostly IPv4, but we do want to do IPv6, and it's quite important for us. Scott asks, does dynamic routing just mean that all the networks tell their neighbors what's on their routing table? More or less, yes. It's that the network protocol is discovering its neighbors. It sends updates of the routing table to the neighbors, and it receives them and sends it to its neighbors. And so all routers should eventually get all of the table from all other routers, and they come to a common agreement across the whole system. Does that make sense? Katrina asks, is it mesh in Lower Bronx? We have a node in the Bronx. It's kind of an experiment. It's very just run by a guy named Bob, and we're really trying to get into the Bronx, but it's kind of hard to get up there because it's quite far away from the rest of the network. So it's in progress, and it's something we're trying to do. I don't think we have anything in Lower Bronx. We have something up by the garden up there, the zoo. So Shiva asks, is NYC Mesh a flat network? I'm not sure what that means exactly, but no nodes are higher importance than other nodes. Some nodes are taller and they have more antennas, so they can see other nodes. So naturally, some nodes have more nodes connected to them than other nodes. So that's yes, please go ahead.
Oh, no, thank you. I just wanted to clarify. I mean, so you said you don't use BGP anymore. So I just wanted to understand that.
Yeah, so we're using a different protocol. We use OSPF, and mainly OSPF for us is good because it can self-discover its neighbors, and then the neighbors themselves are dynamic. In BGP, the neighbors are static. You have to set them up ahead of time. The dynamic part about BGP is the table updates from router to router. But in OSPF, the table updates are dynamic and the neighbors are dynamic. So we've switched to that. There's some good and bad about both, but for us, OSPF is actually, it was a smart choice to do.
Okay, got it. So basically you have one OSPF algorithm. I mean, the OSPF routing algorithm just, dynamically routing through the entire city of New York.
That's right. Yep, we have one OSPF area, in fact, as well.
Okay, got it.
Yep.
Yeah. Thanks.
Yep. Let's see if there's any other questions. Is it mesh in Lower Brooklyn, Coney Island? We have mesh in Brooklyn around Industry City and a little bit lower on the West Brooklyn side. East Brooklyn, we're out to the Saratoga area. We haven't hit Coney Island yet, unfortunately. So your name asks if there's BGP between hubs. There are not right now. We are doing OSPF even between hubs. If it's a good connection, it has a lower cost so that it will prefer to go from hub to hub than from hub to a small node back up to a hub. That way we don't overload the links on the smaller rooftops. So it will always try to take the biggest pipe it can before it goes to a lower pipe, just so we don't clog in the lower direction. We should clog the bigger pipes first. Okay. Any other questions at the moment? Feel free to unmute and ask or put it in the chat. If not, we'll move on to the next segment here. All right, good. Okay, so the next segment here is more about the OmniTIC and how to configure it and what it looks like. So the OmniTIC is by a company called MikroTik. Again, they're not the only company we use, and we don't prefer this company over any other. They just happen to be, you know, a manufacturer that makes some antennas that are the right shape and size and price for us. We use many others as well. So they're a Latvian company, started in '96. They're pretty instrumental in the very early days of WISPs, which we're not. But in recent times, they actually have some antennas that are competitive with other antennas out there. So they have 802.11 AC antennas, they have OSPF, BGP, etc. in the antennas themselves. And as a benefit, all of their routers have all the features. So you know, even if we find a nice new model that they have, it will have the right routing protocol in it. We don't have to buy a bigger antenna just to get the right protocols within the antenna. So there's a pretty good guarantee that most of their antennas will work in our network somewhere, which is nice. They have a GUI that's called WebFig for Web Configurator. They also have one called Winbox, but I wouldn't recommend you use it. So just forget about that one. And it kind of looks like this. They have like a menu system on the side and these little tables, and you click into the tables, and they're kind of, it's kind of unique. So that's one way to do it. They also have a command line interface. It's a little bizarre. It's not Bash, it's not Python. It's kind of has scripting. It's a Linux-based system, but it's a very bizarre command line tool. So they also have some strange things about it, but you know, again, the antennas are the right price and they're kind of nice, but they have no config file. So when you do something, it's immediately saved. But since there's no config file, you can't really flash the router with a new config. You have to kind of run a script. You also can't embed passwords. You can't embed other files inside the script. They don't support folders. So there's some strange things you have to do. And so we've worked around this by, for example, creating a configuration generator that will, you select the model of antenna that you have, and it will create a script which you can download and you can apply to your router. So we've done a lot of the hard work for you, which is kind of nice. And you know, I'll walk through for a second what it takes to set up one of these antennas. So this is what you might do on a typical installation. If you're the install leader, you probably would perform this work yourself before you get to the install. But it's good to know how to do it, and we hope that everyone can do this at some point. So the first thing, you know, for an Omni, what you need to do is there's three major steps. The first one is you need to update the firmware to the latest version. This is quite important because you know, our script won't work with older firmware, and there's certain features that that come into that come in after certain versions, and we've assumed that they're there. So it's best just to update to the latest version. Then you need the config itself, and you can apply the configuration either the easy way or the hard way. The text got a little bit off here. My apologies. So the first way is you have to turn the antenna on and plug your laptop into it. You can either connect to it via the wireless network or via Ethernet. There's a default address of 192.168.80.81. There's no password, and you'll be able to find that your antenna is the right antenna if you're in a room with many other ones, because the name on the antenna will match the address on the back of the antenna box. So if you look on the back of it, there's a little label. We're not going to do that now because we're in different rooms. But you'll see this last 6 letters, and that will match the what you'll see on the front screen. Then what you need to do is update the firmware. You click Files, you upload a file, the firmware file from our website, and you reboot the box. It's very easy. It's probably the easiest thing you can do on this model of antenna. And then you have to upload the configuration that you downloaded from the configuration generator tool. And there's a hard way and an easy way. The hard way looks like this. You have to go to where you downloaded the file. You have to SCP it with strict host key checking off into a certain subfolder. And then you have to go click some things on the GUI. So it's not actually very hard. And then a little song is going to be played for you afterwards when you finish the installation. That's how you know that you completed it successfully. So it's not actually very hard, but it might be daunting for someone who's not used to this kind of work. The easy way is there's a new tool that's available on GitHub that I wrote. It's a configuration UI, and it will even auto-discover routers that are plugged into your network. So you can get it from this URL here, github.com zgilesconfig.ui. It's in the releases folder. And it will even discover networks, antennas you have plugged in, and you can also optionally flash the firmware and apply a configuration at the same time. So it will do all of that for you. It's beta, so give feedback if it works, but so far it works pretty well, and it's about 30 seconds with no typing, so it's pretty nice. After you're done, then you can check your routing neighbors. You click OSPF neighbors, and you'll see what the neighbors look like. We'll do that in a second ourselves here. You can also, if you're on an Omni, which is wireless, you can click on registration, which is a funny way of meaning antennas which have connected to your antenna. So they've registered themselves. And it's a little bit funny way of thinking about it. And you can also look at the routing table. So we discussed in the beginning of this presentation, routing tables and how every router is going to have this giant table of who knows how many entries. And you can actually manually see that by going to IP routes. And it will look like this on the right side, where every network has, it has the network number, the IP address number, and how to get to it. Do you just go out of one of the ports directly, or do you go through another computer and then out that computer? And so you can actually inspect that. So this is not the network we're going to make, sorry. But we are going to make a mesh network right now. I already made one, actually. So the presentation part is over. But what we're going to do is we're going to, I have a simulator here. So this is a bit of a different way. We've never done this before for in person. But here is a simulator which has 5 mesh nodes. And each of these mesh nodes is actually online and is connected to my local network here at home. And so we're going to go ahead and log into router number 111. And we're going to see that it can see router 222 and 333. And we'll see also that it's going to get information from router 4 and 5 through routers 2 and 3. Okay, so we're going to look at that now.
What does Cloud 1 mean?
Cloud 1 is just an artifact. This is actually connected to the Ethernet network at my house. And so you see here it says ENP4SO is connected to 111 on port 3. And on my computer here, ENP4 is a physical wire that goes to the local network at my house. That's just how this simulator represents converting the virtual port to a physical port. Okay, so here's router 111, and we can see it has 3 ports. Actually, I'm going to take this window here. We can see it has 3 ports, which correspond to the Ethernet 1, 2, and 3. So they go to the 3 other routers. Let me see if I can move this like that. Okay, Shiva asks, what is the simulation software? The software is called GNS3. It's a very popular tool for simulating Cisco routers. It can also be used to simulate MikroTik routers and a bunch of other ones. So this is a very good tool for doing this. It's a little complicated to use. but if you have a lot of time, you can figure it out, and it's well worth it to figure it out. We haven't really used it as much as we should have for simulating different mesh scenarios, but I hope we can in the future. So we can see here 1, 2, and 3. Let's see if we can see here. It doesn't show. Anyway, one is connected to this node, 2, 2, 2. One's connected to 3, 3, 3, and one's connected to cloud 1, which is my house. And so we'll go to routing OSPF neighbors, and we'll see that it has 3 neighbors. It has 2, 2, 2, which is expected, 3, 3, 3, which is expected, and it has this other one, which is the home router that's under my desk. So that's my house. We can go to IP routes, and we can see there's a bunch of routes. There's many different paths, but actually we can go to the internet through my home router. We can go to node 333. Oops, wrong one. Anyway, there's a lot of routes because this is actually on NYC Mesh as well. So it's completely on the real mesh network. Here we go. Router 222 goes through 222. 3 goes through 333. And 4 goes through 222. So what this is saying is that to get to node 4, we have to first go through node 2, and then we'll hit 4. And this next one is saying to go to number 5, we have to first hit 3. So 5 is via 333. So we've created a network, the dynamic routing is working, and we have the paths through all of the different routes to each other. And so, for example, we can now connect to router 5. Here's the screen for router 5. So this is going from my desktop to my home network through node 1, through node 3, down to node 5. And we'll see, for example, here, that in OSPF, its neighbors are only node 3 and 4, which is also correct according to the diagram. And so this is communicating by routing through that mesh on the screen into the home network here as well. We can also see the routing table. Yep, so for example, to get to the internet, it goes through 333, which makes sense. And to get to everyone else, it's 333, except for a couple things through 444. Gburger asks, if we turn off 333, we'll go through 222. Yes, and I will actually do that right now in a moment. Olivier asks, what is the main difference between the IP routes and OSPF routes? Good question. IP routes is what the router has interpreted the routes as and is actually using to forward your traffic. So this is the real routing table for the router. OSPF has this neighbors we just looked at, but it also has this routes button. And the routes button shows you what it heard on the network. And so it's interesting sometimes to figure out what was heard, even if it wasn't used. And the IP routes over here, this is what was actually used from all the routing. So you can have, for example, you see over here BGP, OSPF, RIP. You can have multiple routing protocols, multiple dynamic routing protocols, all coming together and interacting. And the IP routes result is the result of all of those. So we're going to do what Gburger asked, and we're actually going to turn off node 333 here. So first, I'm just going to say stop. That's the nice thing about the simulation is you can just turn things off if you want. So I'm still on node 5 here, and we're going to go back to neighbors. It takes a little bit, like a few seconds for the neighbor to go out, but we're going to watch until 333 disappears from our routing table. I might actually have to refresh the page. We'll see. Yeah, I do have to. That's just a little bit about how this works. I could have changed the parameters so that it would be super fast to switch over, but it's just a simulation. Okay, so all it had to do was the network, these 5 nodes had to converge on which direction the whole routing table is. So it did that, and we can see 5, and it shared it with my router at home, and my desktop is able to connect to it. So 555 is now only having one neighbor, 444, and all of the routes are via 444. See, and so we can even check out 111, and we can see that it still sees everything as it did before. OSPF neighbors show that there's now only 222 and my home router, the cloud 1. So basically this network has self-healed itself properly. So everything's working fine and working well in this scenario. Okay, so that's the basics of what we were going to present tonight. This is not the network I was going to show you, so I'll fix that in the slides for officially sharing it, but yeah, there it is. So I will stop sharing the screen and open it up for questions. Please feel free to open up your mic if you'd like to talk, or keep typing in the chat here. Feel free to turn on your webcams. There's something called gallery view, which means we can all see each other. It's kind of nice. Yeah. Scott asks, oh, sorry, go ahead.
Zach, just wondering if part of the goal of having this virtual meet is to kind of help people understand how to set up Mesh so that we can do it remotely, like without the help of other technicians on the NYC Mesh team, or are you trying to do installations through this kind of indefinite quarantine period?
Yeah, so some people are doing installations still. This is a continuation of a series that we have been doing in person for some time, which is this install training. And the goal is, before we send you onto a rooftop, we want to give you the right tools and resources and knowledge to be able to, go ahead and do a good job and to feel confident about your installation. And so when we've been doing this in person, we've been, putting routers on the table, getting your hands on them, see how it works. We've been doing long presentations about all of the different problems you might encounter, what you should bring along with you on an installation. So this is just trying to continue. Most of the install trainer activities do have to happen on a rooftop because you're physically installing it. So there's not much to do on the remote side unless you're trying to fix some problems. So for this time, not everyone is going on physical installations, but for those who are, this is the right knowledge you need to know to do it. I don't know, I hope that answers the question, but by and large, you do need to physically be present at an installation to provide the most help, right?
There's also I'll just add that there's also the DIY. There's a lot of people who do DIY installs. Like if you want to do one for your own house or for your neighbor or something like that to help other folks out that live close to you. And there is a whole channel in Slack that's dedicated to like support, discussion, assisting with that type of install. So that's, something that can happen.
Yeah, that's very true, Scott. There's you can self-install. You can install yourself with, you don't require us to help you. You can just follow the instructions, buy the right equipment, go to a rooftop that you feel safe to go to in your area and help somebody out. And so if that's the right way to do it, you can do that with this kind of training. And of course, we're here to support you and help you. So install leaders, if you can and need help, we will definitely do it. And this kind of training is here to help support you. We have teams of people who are ready to install, yeah, so there's a channel in Slack that you can go to and you can become part of an installation team, or you can find people to do it along with you.
Hi, Zach.
Yes, hello, Shiva.
Yeah, thanks for the presentation. So do we install I actually sent a panorama shot like maybe a week ago or something. So I'm waiting to hear back from you guys. But I had a question. Do we install like an Omni or just a regular router to connect to an Omni, a smaller router to connect to an Omni?
Yeah, so you can do either one. The goal is to have every node be a router. So if you have, for example, just a light beam antenna, which is just kind of this big dish antenna, and it just points to some tall hub, you could run a cable down and plug it into your home router and it will work. But it's not a very good mesh installation because you're not sharing with your neighbors. You're not making it so that the building next to you can connect to your building. And so by putting an Omni, that's the easiest way to handle that because it has an access point outside. Other Omnis in the area will discover your Omni and they will automatically connect. And other neighbors can run a cable to the roof and plug in directly. So the Omni is the best way to do it. If you want a different topology, you can have a small router inside and connect that to the light beam. There's configurations available for that. And you can put more antennas outside that plug into that one. So there's a whole variety, but the Omni is the best way to do it.
Okay.
Yeah.
Thanks.
Yeah, that's the recommended way. And it's the most cost effective and it's the easiest to share and so on.
And Zach, this is Olivier.
Yes.
We install Omni also. It's a way to be able to expand the network and to share among the neighbors. It doesn't mean it's only on Omni. Depending on where you are, it could be an Omni plus a light beam.
Yeah, exactly. Yep. Yeah, the Omni plus light beam, maybe with 2 or 3 more things. But you know, the minimum is just an Omni. If there's another Omni nearby you, and then you know, maybe an Omni and a light beam, maybe an Omni and a light beam and sectors. So the Omni is core to the idea that you can expand the mesh, which is kind of it's our calling to do that. So if you can expand the mesh in the same way that it came to you, which is, you know, open and accessible, then that's the best thing you can do. Yeah. Other questions? Let's see. Is the installation team on the NYC Mesh workspace on Slack? Yes. There's a channel called installs or install, and there's another one called install team. So please join the installs channel and you know, note your interest in becoming part of install team. Yeah.
How do we join the Slack group?
I think you go to our website. Let me see here. I can probably.
Yeah, unfortunately, it's at the bottom. It's not prominent on the first page anymore. I think Oliver won't. I don't know why it moved down there, but it's at the bottom on the front page.
Actually, I'll share it here. If you go to our website, nycmesh.net, and you go all the way to the bottom here, it says Slack. And so you can actually go to slack.nycmesh.net, which will take you directly into Slack itself. So by clicking that, for me, it already takes me there because I'm already logged in. But if you click this down here, it should allow you to join the Slack.
Oh, thanks.
Yeah, sure. Chris asks, if we can't install on the roof, can you do it from your window? You can. However, depending where you are and what you can see and what kind of windows you have, it might be a bit of a problem. Some of the newer windows block the radio signals. You know, the Omni, for example, with that donut-shaped antenna, really is designed to go 2 or 3 blocks and hit another similar antenna. And so they're really focused on going from rooftop to rooftop. So you can, but you might have some challenges. So it really depends. It's a case-by-case basis. But you're welcome to install in your window. It's not a problem. There's no limitation on it. Yeah. Let's see what else. Using Google Earth, it seems that my building was incapable of connecting. Would I have to get one of those tall buildings to install? Yeah, so we can't do mesh right now through buildings. It's a point-to-point thing. You have to be able to see the other antenna. You may not have to see it with your eye, but you can see it with the radio. So there has to be space in between you and the other antenna. So if there's a tall building in your way, you might be out of luck. But if you can jump around the tall building, because it's a mesh, so you can have as many antennas as you want. You can have another short building nearby or a tall building that you can see, and then that short or tall building can see some other tall building. So, you know, it's resilient. You don't have to have the tallest building ever. You just have to have a path to the other side somehow.
And I would like to add, line of sight means really a line of sight. If there's a tree in between, it reduces the signal a lot. That's
true, yes. Another Zach asks, can I use my own balcony? You can. A lot of Mesh members have installed in their balcony. That's very much welcome. It depends on your building. So, you know, do what's right, but you're definitely allowed to install in your balcony from our perspective. We don't have any notion about yes or no in any of those cases. And it has been quite effective for a number of people. Okay. Let's see if there's any other questions, please feel free to ask. Oh, here's one more. Can I do it from my air conditioner and have a direct site to Verizon? Okay. Yeah, we've had some ideas about making like a fake air conditioner box that has an antenna inside of it. So if anyone feels like doing that, that'd be kind of fun. But some way to get it out of your window without interfering with fire escapes and balconies. And trees and leaves definitely come into play. Yep. Okay. Well, it's now 8 o'clock, so it's been 1 hour. And if there's any other questions, please feel free to open up your mic and or webcam and ask them, or put them here. We can leave the meeting going for a while if you'd like. Yeah, if nothing else, then I think that concludes our install training. I'm happy to demo anything else anyone wants.
One quick question, if I may.
Yes, please.
Is Cat 6 cable available for outdoors?
We're not really partial to Cat 5 or Cat 6. It doesn't matter very much. We're not doing anything at a rate that requires Cat 6. We typically use this cable called Ubiquity Tough Cable because it's waterproof, it's outdoor rated, it has a shielding on it, and I believe it's Cat 5e. But in any case, it doesn't really matter if it's Cat 5 or 6, to be honest, in this case.
Just for future proofing, that's basically the reason for asking. But thank you.
Yeah, you're welcome to use Cat 6. There's no problem from either side of our perspective. But we generally don't, just because it doesn't make any difference, and we prefer the tough cable.
Okay.
As long as it's outdoor rated.
Yes, that's the most important thing, is that it's outdoor rated and that it's the right kind of cable so that it functions well all the time. We've had a lot of problems. Olivier can probably say that we've had problems with connectors that get water inside of them. We've had problems with cables that the jacket starts to peel off, all kinds of different problems. And it's not worth skimping on the cable, we feel.
Thank you.
Yeah, of course. Yeah.
Just one last question. Hey, I know that it's been a little tough right now, I mean, working, but then I just wanted to know if there's any way we can help in, if we need to, how do we know if we have a good line of sight to the nearest Omni or the hub? Is there something we can do to help?
Yes, let me bring up a couple of pages here. We actually have a line of sight tool that you can use to find the nearest site to you.
Okay.
Hold on a second. Let me change my screen. Okay, so it's actually at los.nycmesh.net, standing for line of sight. And the map is empty at the moment, but if we type in an address, let's say, what's a good address? 100 Broadway, I don't know. We can see, oh, that's apparently not a good address. Anyone have a good address you want to use?
477 FDR Drive.
Okay, there's one. So yeah, good. So here's 477 FDR Drive. We can see that according to this left side, or the left side, you can see 1, 2, 3, 4, 5 hubs. This, you may not be able to actually see all of them, but it's predicted that you can see these ones. So for example, Henry Street is a very likely connection because it's just straight down this block right here. Rivington Hotel is pretty tall, although we don't have a sector on this side. So, you can see how it has this kind of fan right here. It's about a 200 or 300 degree sector right here. So it might work just barely on the edge. Supernode 1 has a sector this direction, so that'll work. This one, I don't know why it's showing us Gail Brewer's office because the sector is the other direction. But in any case, this gives you an idea of antennas that are registered as something that you should be able to connect to, and what kind of antennas on the other side, and what the connection can look like. There's also some planned ones. For example, this one, yeah, it's very planned. Yeah, we can forget about that part. But anyway, this is a way to easily tell. Yeah, this is the recommended way to find if you can see a hub or not.
I went on this website and put in my address, which is in Fort Greene, and I think is within network, and I get an error not found. Is that sounds, is that weird? Or
you say you type in your address and it didn't it said error not found?
Yeah.
Okay. Yeah, so this is just this part right here where you type in an address is actually just it's just Google Maps API. So it's best to type it in, and then when the drop down happens, click the right address.
Got it.
Yeah, it's a little bit finicky just because it has to be a properly formatted address, and this drop down does that for you. But you know, it might have it's hard to tell.
Yeah, I clicked it and still not working.
Would you like to say your address?
I guess I can share it. It's 86 Fleet Place.
86 Suite, you said?
Fleet, yeah, like a fleet of ships.
Fleet Place, okay.
Yeah.
Okay, interesting. Error not found. I don't know what that means, but we can tell it to the author of the tool and see what he says.
Cool. Is that a Slack channel that maintains this tool?
Yeah. Let's see. It's probably actually. Let's see. Maybe website would be a good one.
Okay, cool. I can just post it in there so you don't have to like ask on my behalf.
Yeah, it's okay. Either way, yeah, I'd say website or maybe support. Support's another good channel for this because it's kind of like something's not working. Or yeah.
Cool. Thank you.
Yeah, sure. Olivier, did you have something to say?
No, I was thinking probably website, and I would post it to @Oliver.
Yeah,
He's the one who developed it, so he would know why. It's probably because it's not in the database he's using.
Oh, interesting. Okay.
Yeah, I agree. Yeah. Put in the website and @Oliver. Yeah. Yep. Let's see if there's any other questions in the chat here.
There was a question about the Link NYC, I think.
Okay, yeah. Link NYC is not us, but it's another good alternate for free internet in the city. You can easily use it on your phone or other things like that. We have on our website a how-to use a MikroTik branded antenna to connect to it. Olivier, I think you're making a lot of noise. Hope you're done. Okay, sorry. Yeah, so we have a how-to on our website about how to use a MikroTik branded antenna to connect to Link NYC, which you're welcome to do, but it's not us, and so you know, it's not very difficult. You can even use the config gen tool and the config UI to connect to it to generate a configuration. It maybe takes about 20 minutes of work after you have a MikroTik antenna. Certain models are required, so it's a bit of a challenge to get that model. You need an international version, so that's a bit of a problem. You can buy some other antennas like a NanoStation 5, which is a pretty old antenna, but you can use it for this purpose.
Actually, question sort of piggybacking off of that. Are there any instances in the mesh where someone is connecting to a Link NYC kiosk, but they're also in the mesh such that there could be like a route to the internet that sort of resolves to that kiosk? Yes,
definitely. Yeah, actually the mesh started about 4 or 5 or 6 years ago, where people were primarily sharing their Time Warner connections with each other. And that was the kind of the big goal was because Time Warner was down so much in different people's buildings, you could jump to each other. And so even now we maintain the capability that you can expose a default route to the mesh from yourself. And there's a proper costing you have to add to it. So if it's a low quality route, you should add a certain amount of cost. And if it's a better quality, a little bit less, and so on, all the way up to a super node exit. And so we have, for example, someone in the Alphabet City area that has a kiosk exit that's not used because you know, the super nodes are still online. So if all other paths are lost, they'll go out through the kiosk.
Gotcha. So the probability of like my traffic if I'm meshed in with someone, exiting through a kiosk is pretty low unless something is up with the supernodes.
Yeah, that's how it should be. But remember, it's a community network maintained by a bunch of different people, so there's no way to guarantee it because people have to set their routers appropriately to say, you know, this internet that I'm connected to is a low quality internet.
Yeah.
Or it's an undesirable internet.
Yeah.
Yeah.
Thanks.
But certainly, you know, with the whole dynamic routing concept, you know, the internet or default route is just one more destination you can go to. And so you can have many different paths to it, and you'll just take the shortest path to it.
Sweet.
Yeah. So let's see. E. Lee asks, how big has the mesh gotten in terms of routes? And you ever carried a full table on the microtik hardware? Do you try to get everything in there beyond some arbitrary path lengths just to drop it in default? So the mesh itself has about 1,000 or maybe 1,100 routes in it. We can probably bring it down a little bit, but it's about 1,000 or 1,100. That's not too many, you know, since we serve about 400 something buildings maybe, or 380, 400 buildings. There's about 500 and something nodes, but some buildings have 2 or 3 nodes. So that's fairly reasonable. We don't dump the BGP external table into the mesh. What I mean by that is we as an organization, as a community, maintain a public network. So we're on the internet in addition to having this mesh network, which means that our IP addresses are independent of any other ISP. So we ourselves peer with Google, Netflix, Amazon, all those people directly. So we don't take that table and dump it into the mesh, just because that would be super inefficient. We just expose a routing table. We just expose a default route on the supernodes, and the supernode's goal is to do the right thing. And so so it's just the 1,000 that are inside. You can get to the internet using BGP across the mesh if you want to, because that's kind of a cool thing to do. So if you want to do that, it's possible. But we don't, by default, just dump everything in. But yes, in terms of internal routing only, it's you know, about 1,000, 1,100. We do not cut off at some path length. We do not drop any routes. Every router sees every route from every other router across the whole network. And the reason for that is because the network is public service. It's for everybody. There's no like, you're not allowed to see it. Everyone gets all routes all the time.
Thanks, Zach.
Yeah, sure.
Good informative session.
Yeah, sure. No problem. Thank you very much for joining. Any other questions? I'll be happy to answer them. Otherwise, I think maybe we reached the end of the training. But again, happy to demo anything. Please.
I've got a good closing question. What do we have? Sure. You said this was the second in a series. What do we have to look forward to next week?
That's a good question. I don't know. Let me look it up. The first one was a generic install training thing, I think. Yes, the next week one is how to crimp and configure. So it was supposed to be in order of the basics, how to do rooftop installations, how to do crimping, and then I was going to wrap up, but we switched the session 2 and 3 because we wanted to mail out crimping kits to anyone who wanted them. So if you want a crimping kit, get on Slack and ask for it.
Which channel?
I don't know.
That'd be just like install.
Yeah, maybe installs or maybe meetings. There's a meetings channel, so this is, you know, you can ask in there.
Cool.
Yeah, so this one is just the networking basics, the one-on-one, and so on. Yeah.
Right on.
Yeah, no problem. Okay. If there's any other questions, I'll stay around a little bit longer. But other than that, thank you everybody for coming. Much appreciated, and I think it's a lot of fun. So.
Yeah, thank you.
Thank you.